Alright, we're alive. Not sure why that's twice now that's done it. I don't understand why. OBS is doing some funny things. I had trouble with the face cam, with the mask. It wasn't doing the mask properly. And then it's forgetting which source for the audio. So I think it's an OBS issue. Alright. Anyway, what I was saying silently before is that this is our first prototype. And there's already going to be problems because I don't have the right relays at the moment. I've only got 5-volt relays on hand, but I need 24-volt relays for this. When I say 24-volt versus 5-volt, I'm referring to the switching coil voltage, not the contact voltage. So all of the ones I've got, I've always traditionally had 5-volt ones, and this is going to be a 24-volt relay. So yeah. Anyway, I can bodge it by routing the power instead straight through the switching MOSFET for the coil. It's only going to be 700 milliamps, and the MOSFETs I got will handle that perfectly fine. They'll handle 2 amps in that sort of SOT23 size. So the idea behind this is that I will integrate these cheap compass modules. What are these? 5883 compass modules. I don't think you can even get those chips anymore, but you can get the modules. So we're going to put that on there, and actually we'll be pointing that way. Build it up, see what we can do, see how we go. It's not a very complicated circuit. It's just lots of little bits and pieces. Where it's going to be a little bit complicated is that I am not sure if my Tiny 212 will have enough space in it to handle decoding the compass values, because I've got to basically implement a arctan2. And arctan 2 is not too much of a problem because it's actually just 4 tests. The real problem is actually implementing the tan, which means I've got to implement sine and cosine, and yeah, it's going to be interesting to see whether I can fit that. I may have to actually move up to a tiny 214 or a 412. I can't. It's the 4K version of this chip. So anyway, let's get it built and go from there. So there's not going to be any pasting on this one. This is going to be a hand done one. So that should irritate enough people to get us started. I did get other goodies today, thankfully. Things that I've been waiting on. So it's going to save the day. I'm able to start shipping out stuff again, because I got this lovely box of lots and lots of LCD displays, as well as the connectors. So that's a big help. Gets things moving. Pre-calculated would fit in Flash, perhaps. Oh wait, no, it probably wouldn't. Because at the moment, when I think about it, my USB-C meter, it, I'm not sure. We're just going to try it and see it. If we've got to go up to a 4K version, we've got to go up to a 4K version. It'll just be the way it's got to be. What to put on there first? So many exciting choices. I'm going to have to break out. Let's see. I'll do this mostly under the microscope. Makes it easier for me. a little bright. There we go. Just trying to work out what I'm doing here. Let's see. I think that's all the parts prepped. We will find out. Hey there, Keith. Sorry, I'm going around in circles here because I'm trying to remember the positioning of all the parts. I mean, I've obviously got the board view and the schematic next to me, but I'm trying to remember just from memory. So I've got this great big 5 volt regulator, which you probably recognize from the ring light. So that's going to give me 5 volts off the 24 volt input, and then I've got a little 3.3 that I'm going to be using to get me down to 3.3 volts as well. The 5 volt might have been redundant in the design, but I left it in there just for now. Do you really need to calculate the angles? I'm going to work that out in due time. I will worry about that sort of problem when I get to the point where I've got to worry about that sort of problem. In the meantime, I've got to worry about simpler things. Like build it. Trying to put the cart in front of the horse. And then you're going to go, you were talking about it. So that was the preamble. Hey there, monk standing. Not sure I know that name. Shouldn't do that, Paul. You've only got enough flux in the wire for one hit. Me just being naughty. How is it that people are not getting... I'm surprised you weren't getting duplicate audio then, because... Yeah, anyway. Hey, Tony W. So I don't know whether OBS has, like I said, an issue with this particular release or what, but... maybe I've messed with something. These are the I2C pull-ups, 4K 7 each. That's not sitting down properly. What are you going to do? Nothing at all. It's a prototype, for flip's sake. It's going to be dodgy. The micro pencil is just a little bit too small for this sort of work. I mean, I'm dealing with 603s here. It's kind of ridiculous, you know, 603, and look at all this pad space that it's got around it. I got a fat diode there. That's actually for the relay coil flyback protection. I don't think we'll be going to need it in this instance. Yep, they're in the right way around. See, dot there, dot there. Yeah, the collapsing field of the coil when you disconnect the power to it, you got to get rid of it Otherwise it can get quite a high voltage develop across it, and then it can shoot through things. And you don't want that. So yeah, you just put a reverse biased diode on there, does the job. Let's see, what do I want? I want 100 ohms or something like that. 150 will be fine. This is just the gate feed to the MOSFET. It's not super critical in these situations because you're not switching thousands of times a second or anything, and you're not too worried about your gate charge heating things up as you move it back and forth. So 150 ohms is perfectly fine, and then for my default pull-up I'll just use a 10k, which I don't have. Alright, fine. Let's make it a 4k7. Actually that's a pull down, not a pull up. Basically the point of that is that if when you close the when you tell the microcontroller to turn off the MOSFET, then this 4K7 to ground, it just sort of stops any sort of induced stray voltage coming up, because there is a small amount of capacitance in that gate obviously. Let's see, for the MOSFET we'll probably use something like a 337 I think, or a 307. Can't remember which one I prefer. Mind you, I could use a PMT20 I think I've got. I think that's what they were. No, I don't know. Prehistoric MOSFETs now. Back in the day, it was just like glorious having access to some of these. It was like, wow, 100 milliohms on resistance compared to 5. Oh yeah, here we go, PMV31XN. Let's see, what are my other one? FDV301s are too much, no. FDV337 is the one I'm thinking of. And I do not have any 337s. That sucks. So I guess it'll be a PMV31XN. These are really nice MOSFETs. Ah, creature, you're gonna have to make me read shit. We'll see, we'll see. So if this was the MOSFET I was going to use for just switching the coil, I would not be using this particular one. It's a horrendous overkill for that purpose. But since I'm going to be passing the LED light through this, because it's a bodge job, then it's a better choice. The 307 unfortunately has about a 4 ohm resistance, so not 307. I don't have the 307 listed here. The 337 is good for about 2 amps. The 301 is miserable at about 200 milliamps. But yeah, like I said, the PMV 31XN, I'm happy to use that one. It served me very well, that MOSFET. And of course we've got to have the permanent indicator that there is actually power in here. The over bright green LED. that I've now made slightly less bright. Kind of flooded the leg a little bit too much, probably damaged it ever so slightly. We're not connecting that up. This here, if I know that this board is going to be connected to the computer, then I can put a 0 ohm resistor there and then do away with this regulator, but I'll still need the 3.3. But I'm also wanting to try this out as a freestanding device, so we'll be playing that one out tonight, the freestanding device version. And I've got a button here that I need to add. I'm trying to think, why do I have a resistor there? 1K. I'm a little unsure why I've got 1K there. Actually, it's very strange, my button configuration here. What was I thinking? I don't know what I was thinking here. Usually with buttons, what you do is you rely on an internal pull-up in the microcontroller, and then you pull these to ground. That's just the simplest way of doing it. It means you don't have to have any resistors external or anything like that. Anyway, I'm trying to work out, so that's it there. And then it's... What the hell? Oh, right, I understand now. That's going to be a problem. Okay, the idea I kind of had was if the relay wasn't going, then I was going to use the button to drive it to turn on by pulling up to 3.3 volts, which would basically be the equivalent of the controller. Wait, what? What the hell's... Oh, it's not. It's going into here. Right. I was going to say, what's the CH340 doing with that? So it's coming out of pin 7. Yeah. Which is the relay enable pin. Pretty sure, let's see, pin 7, yeah, relay enable. So basically what's going on here is I am making the button act like this chip going high. I probably should have diode protected him, by the way. That was a mistake by me. Anyway, this is why you do bodge jobs, because you know you're going to bodge them up. And a lot of that's driven by the fact that I'm basically running out of pins on here to do what I want to do. It sounds silly, but it's true, because see, if I want to do bidirectional comms, that's 2 pins off there. And then I've got 2 pins for the I2C. So we've lost 4 pins. And then you got the UPDI pin, so it's 5. That, you know, all of a sudden you're basically out of pins. I know you can do a high voltage version, but I'm trying to avoid that if I can. Alright, let's mount up the sockets. I don't need a color printer. I just need to remember what I'm doing. I'm not moving to STM32. What a waste. I just moved to the 1 series AVRs from the old stuff. I mean, yeah, sure, if you've got your big fancy projects, you go ahead, use those STM32s. Using an STM32 on this is kind of like using a sledgehammer to crack a walnut. Why stop at the STM32? Let's get a Raspberry Pi onto the job. That'll be a better option. Hey, Teresa. We should have gone total Raspberry Pi on this. Loaded with Ubuntu. Teresa, did you get that switch light back together? Salty pool. Yeah, I don't think that's a term I want catching on too much. I suppose it's better than Scratchy Jack. Not yet. Seriously? Hasn't put it together yet? I can't believe that. What sort of child do you have? What sort of child can restrain themselves from putting back together their gaming device? I'm looking for my box of headers. Where's my goddamn box of headers? Where are you, headers? Ah. Oh, what in the living daylights? Have I got metric versus imperial bullshit going on here? I have, haven't I? Stuff used SparkFun. Alright, it fits, but it's basically, it's 5mm versus, yeah, something else. Goddamn SparkFun library. It's not so much a snug fit, but rather a splayed fit. Those legs have been stretched out side to side. Oh well, it'll work. And what in hairiness have I forgotten now? I think there's one pin here that I don't use, and that's the That's the interrupt pin. I need to get all this hairiness off. Yeah, I need to drop this header off. Because otherwise it's going to be all in the wrong orientation. Get out, you mangy beasts. I need another pair of pliers. I might just slide these off and take them out individually. Better yet. Ow. See what I mean by this stuff is all puffy? It's no good for the work we do. Flippin' hot. And anyone tell me that hot things get hot? Oh, you've been an idiot, Mr. Daniels. There's a very simple way about this. Oh, they really don't want to come out. That was far too complicated and long and annoying. Should not have been anything like that. Oh, you son of a... So there's gonna be one. Okay. The board desperately needs a wash. I don't know where it's been, or I don't know much about this one, other than the fact that it's one of the two I bought, but not the one that I use. Yeah, it's still looking pretty ugly and roasted. Hopefully it'll work. Okay, so that should be our 3v3 line there, which is there. So we're lining up like this. Just find some straight headers. Ah, here we go. Some very cheap, ugly, nasty ones. I'll be lucky if these are plated with anything other than crapitanium. Where is that solder? Huh, it's actually not too bad. I'll take it. I could socket this, but I'm not going to. Hopefully I will not lament the day that I decided not to socket it. Make sure I double. I should check before. Yep, that's 3.3 volts. Okay, so we've got 3.3 on that. That's good. Okay. It's going to happen one day with that Earth discontinuation magnetic field. Or we just put a negative sign on everything, but of course, if only it was that simple, we know damn well it's not going to be. In fact, there's probably just going to be hundreds of years where it's all over the place. And lots of screaming people. Hopefully by then, though, we should have sufficient things flying around in terms of satellites that we can get away without needing the magnetic field anymore. But it's awfully convenient. I think the bigger problem is going to be all the birds dropping out of the sky and stuff like that, perhaps. I now need to get a button. Trying to think what project I'm working on that had nice buttons that I was using. Oh, it was the DT880, that's right. DT880, do you have buttons for me? Choosing buttons can be quite the process. How about a light up button? How about not? What? Looks like I've been hit again by the... God, flip a dick. I mean, whoops. Can't say that, Paul. Oh, wow. I copied the wrong damn button flipping outline. So now I've got to go to my box of buttons and find something out of that. Anger. So much anger. Where are you, switches? Switches. Oh, right up at the top. Hey there, Toby. Alright, so can't use that. Can't use them. I mean, you could if you wanted. You could splay the legs out. Oh, those, right. They were supposed to be so I could change my mouse. Nope, not you. More mousey changes. Not you. Creature, That's not going to happen. Besides, why would I deprive myself of the pleasure of my own stuff? I'm going to hand it over to you. You got your own job. Do your own job. Leave my job alone. Blue cherry switches. Yeah, okay. Side mount switches. I could use things like this because we only need one side. Four-legged switches basically just have the same switch. More rotary encoders. Bag of right angle switches I'll probably never use again. More mechanical, nah, tactile, yucky, they're no good. What are you guys doing in here? Solid state relays, alright. Don't know why you're in there, but you're in there. Here we go, these might work. Maybe not. No, they're just... yeah, nope. That's a nope. Hey there, Carrot Dog. Good to see you. That's a nice chunky switch. But if I gull leg these, in other words, if I fold these legs in to underneath, it actually would fit. I mean, I could just, yeah, what do you call it, fillet solder all the way out. What about these ones? These look ugly. They're pin through. Goddamn pin through. Pin through sucks. Reed switches. Magnetic reed switch. Fantastic. Useless. Here we go. Suicide switch. I might just have to flood, yeah, well, what do you call it, fillet fill these ones. Because I could do that. Which way, actually, which way is this switch going? Oh, we're going left to right. Okay, that's out. I'm up, yeah. Let us hope that a nuke did not launch anywhere. Still definitely top on my fear things ever since I was a kid, living through the after effects or the Cold War itself. It was not fun. I'm kind of surprised. I really did think I had more surface mount type ones. This is the size I would probably actually want to use. Let's see. Trouble is, I can't really gull leg them because it's not wide enough, so I wouldn't be able to get the solder under there. You are so annoying. Alright, looks like we're back to how we were, but we're going to have to just offset slightly and then fill it. On chat on mobile is covering, just scroll. Oh, right, okay. Why are you chatting on mobile? So here we go. We're going to go nice fat fillet of solder. There we go. Embarrassingly fat. It's tagged. I'll obviously change the footprints for the next time. You got to be careful too with these tactile switches. You put too much heat into them, it does ruin the switch membrane. Pudding, 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 pudding. Let's see if it actually does do its job. Sounds good. I think we need a bit of a wash down now. All this stickiness is annoying me. Hey there, Gary Field. Welcome. Okay. Let's see. Pure IPA. Let's sit there for a little bit. The relays that I'm after, they did get shipped today, but I don't know where they're coming from. All I know is they're coming via DHL, which means it's going to be a 3-day delay, even when it gets into Australia. I'm not sure what warehouse they've been shipped from. The fact that it's been shipped via DHL tells me that it's not in Australia. And I'm fairly sure when I ordered them that they were showing no... It was all UK stock from what I can remember. So, but yeah, coming through DHL means there's going to be a 3-day delay when it could have already been here. Oh well. Right. Righto. There we go. There's probably going to be plenty of flux scum. Yep. Goddamn rebel flux scum. Yuck. That's why we have an ultrasonic cleaner. Alright, well, first test is we just plug it in and see if it goes up on smoke. Nothing fucking works. I mean, nothing works. Someone's angry tonight. C was angry tonight, my friends. Okay, so nothing worked. Wow, why didn't even the 7805 work? Alright, now the fun begins. Would have expected that 7805 to work. Did I put the LED on backwards? No. It's getting hot. I get the feeling I might put the LED on backwards actually. That would be smart. Okay, ground. 3.76, that is massively incorrect coming out of there. 22, it's also incorrect. 2, what's holding this whole board down? I know what I've done wrong. That's freaking hilarious, I've done it wrong like that. Wow. Alright. Or have I? No, that's correct. Resistance checks. Especially just a LED. I mean, come on. I mean, that's 800k. There's definitely no problem on that rail. 1 meg on that rail. Well, what's going on? Have I got a floating ground somewhere? Did my ground not get attached? That can happen sometimes. Ground. Oh, you're good. Ground. Yeah, you're good. What the hell's going on? Didn't bridge anything. Unless this is causing problems, but I can't see that being the case. And this does not require any capacitors to stabilize. I probably should, but it doesn't actually require them. Yeah, I'm a little stumped here. Because basically, off the 5-volt rail, this is the 5-volt rail here. That's all that's on it. The cap and the regulator. Oh no, this doesn't need a 10 milliamp bleed either. Yeah, the ICs are correct. I said pin 1 there, 340, 212. And this is the 5-volt one. I'll take this off, and I should definitely get 5 volts. I mean, unless it really is wanting some sort of... But this here should be providing enough draw on that output to help it regulate. It's kind of weird that this is only giving me 22 volts, though. I would have expected a full 24. Just testing the... At 24 volts, so to get that to sync to 22 is quite a feat. Which means that must be... That's definitely input, output. I'll take VREG 2 off and see what happens. It's just really strange though. Yeah, there could be that's wrong, but I'm fairly sure if we look at the USB-C meter, that's how it is. Yeah, this is the USB-C meter. But yeah, like 5 volts coming in. That's the regulator there. And again, center pin. And then ground and output. So center pin, ground, output. The way it's behaving, it's like something's been shunted pretty hard to ground. The input jack, no, those 2 pins there, they are joined together. These are the ground ones here. Yeah, I've got the probes reversed, doesn't matter. 16 volt? What the hell's going on here? Why am I seeing 16 volts? 15 volts? What is going on? $24 volts there. What? Okay, 24. That's weird. I must... Oh, I know what's going on here with my measurements. This shield is not connected to ground anywhere. That's why. That's why I'm getting crazy shit values. Right, 4.99. That's more like it. Hello, Harold. Alright. So that was a bit of misdirection. Still, which means we could be back to just the LED being backwards. Right, now if we use a proper ground, might see 3.3. Yep, 3.26, so the LED is just backwards, that's all. Hey, we got the light. That was stupid. Stupid thing to make a mistake on. Oh well. Looks like I'm human after all. I'm trying to think of the next process for me to take on. I really need to rig up one of my ring lights. One of my dud ones or something. Oh, maybe not the dud ones. Just can't remember if I've got a 2.1mm plug. I don't want to have to go nipping off the lead off another power brick. I've done that too many times to the point where I've got all these power bricks without plugs on them. It's really stupid. Yeah, Harold, that's true. I forgot about the fact that once you do that, it will go into the shield of the computer. 2.5. Well, you could use a 2.5 and a 2.1. Because most of those jacks, the tongue in them, the spring tongue, it pushes up that small distance, that small gap. So it usually works. No idea why I've got right angle version, but anyway, it looks like I do. is different. What am I doing here? Right, I need to make a lead that's going to go from here, from the 2 points here where the relay coil is, off to this. So I just need to get some wire. I'll get some black and white silicon high flex wire probably. Ah, there you are. Daytime weather is tolerable here now. Tolerable is about the word for it. Nighttime is finally sort of getting to the point where it's cool enough you can do something without the air conditioner on. Right, please excuse my trash fest here. Yeah, they're close enough. Maybe I'll use some of these ones that are already unspooled. Right, I can't use this because I know this off-coloured red, that is actually meant to be for the ultrasonic tank, because that wire has been dancing around in ultrasonic fluid without actually having been rinsed. So it's definitely not a good idea to use that. It's probably corroded inside. Kind of don't want to use this wire because it's actually nice, small. I think, what is this? Feels like 28 gauge maybe. Yeah, it feels like a nice pair of good fine wire, whereas this stuff's I think about 24 gauge, so it's a lot more common in my workshop. So I'll keep this aside. I've got plenty of junky servo lead wire. Oh, what are these? Oh wow, need to throw these out. Anyone know what these are? The noise alone the noise and the profile should give it away what they are. Mind you, if you do know what they are, it means you're probably an old electronics person. Oh yeah, that should about do it for 1 amp, 700 milliamps. Stop messing around, Paul. It's already 11 o'clock. Yeah, B-Blood's got it. They're for antenna formers, coils. Yes, you should see my wire with a bunch of, my drawer with a bunch of wires in it. Pay no attention to my spaceship. Okay, this is actually mismatched, but I don't care. This is really just purely for the sake of testing, no other purpose. Those wires are definitely mismatched. One thing I do love about... No, I can't do it with my gloves on. One thing I do love about silicon wire, of course, is that it's so easy to just... Yeah, that's just too thick. Why can't I win tonight? Can I just have a time where things go smoothly? Yeah, is that too much to ask? Yeah, apparently it's too much to ask. Fine. Fine. Fine, you filthy little wires. Fine. You win. You win. You get to get used. Damn it. I'm going to use a small portion of it. There. You got to appreciate, a lot of those wires have been in there a very long time now. They come from the days of when I was doing model aircraft manufacturing electronics. And that is a long time ago indeed. I'm not even sure how I want to wire this damn thing. Oh, you got a compass module here. Beep. Good God, I'm an idiot. That's why I got to use the microscope. I didn't even see that that actually did not solder. It soldered the wire, but it didn't actually solder onto the tab. That's how bad my vision is, even with the glasses. We'll try and solder that center pin properly again. More flux. Oops. Fairly sure that's soldered now. No idea what that landed on, but it complained. Oh, thank God I didn't have to thread that. I was worried for a second then that it was one of those situations where you need to keep the outer portion attached during the process. It appears not to be that case, thank goodness. It's a very strange attachment style. It's just like a pushover fit. Not very confidence inspiring, that's for sure. These high flex silicon leads, they're really actually quite good as a source of fine wires for doing board repairs. And they're cheap as. Come on. Some serious suction going on there. So I do love my extractor system. If Graham was here, he'd be complaining that he's missing out on the olfactory element of board assembly. Like, you can't smell when it's burning. How are you supposed to know when to stop? Alright, for this bodge assembly, I have to put ground on the left, red on the right. So effectively what happens is when it's off, it's detaching ground. That's how most of these sort of things work. You may hear the term low side switch, and that's basically what it is. It means it's disconnecting the ground away, as opposed to a high side switch where it's disconnecting the positive rail. Low side switching is a lot easier and more efficient in most cases because N-channel MOSFETs that we use have a superior on resistance compared to P-channel, which is often what you have to use when you do high side switching. However, there are complications when you do low side switching depending on your circuit. Sometimes you can get weird float up issues, like the rails will rise up in a way that you can potentially see the full voltage across your device that's being detached. So it can make for some interesting complications. But like I said, the downside of high side switching is you've got to use a P-channel MOSFET in most cases. And they have a fairly high resistance for the same technology. I did not reflow those wires very well. Again, not looking at it through my microscope, so I didn't see it. And stupid pin through crap. Okay. So because we don't have a relay and because we're too impatient to wait a few days for the relay to arrive, we're going to do it this way. I'll go get a sacrificial lamp. Hey, Mimi. No, the front plug does not have a cover. That's just how it is. It's kind of why it's ridiculous. Okay. Alright, see if this works. Yeah. Alright, so we know that that teeny tiny little MOSFET that we've got there, that's doing its job just fine. Wow, that 7805 is getting hot. Not painfully hot, but it is getting hotter than I want. I mean, I know it's dropping. Yeah, it's dropping a long way. It's going from 24 volts down to 5. So you've got you got 19 volts there. So for every 1 amp of current you draw, or every 1 milliamp of current you draw, you have to dissipate 19 milliwatts of heat. So you're trying to minimize the amount of current you draw on the low side, on the 5 volt side. Yeah, that's a pretty. Which is why I'm going for a 24 volt relay, because with the 24 volt relay, I don't have to draw any of that power to hold the coil through this. I might end up just actually ditching the relay idea and sticking with the MOSFET, to be honest. Yeah, that might work. We'll see. I just kind of like the idea of a relay because it does galvanically isolate everything, so no matter what happens on what you're switching, or what happens on the switching device, there should be no interaction between the two. A little heatsink, that's what the big fat copper plane is for. Okay, so that's the initial simple part. So we know that the mechanics of the board work. We haven't even bought in the compass thing or the tiny 212. For the 212, what I'm going to do now, yeah, that really is actually, I would love to know how much current that thinks it's drawing. Maybe I'll put a 1K resistor or something, because just the power to run that LED, as bright as it is, could be more than enough. I mean, the 7805 does have its own level, fairly high level of quiescent current, so the sort of power it draws even when you're not doing anything at all. But I'll just bump up this 150 ohmer to something a little higher. Let's see. Eeny, meeny, miny, mo. Pick a resistor. We'll take a 300, please. 300 says I'm empty. 330. Okay, we've got plenty of 330. Ooh, 4-digit ones. That's nice. 4-digit values are always nice because you can read them straight up. 330. Oh. Okay, so that's more sensible. Maybe it doesn't show up on your screen so much, but it's more sensible here. It doesn't flare out when I'm looking at it. Okay, yep, software time now. Whoops. So what I'm going to do here is I'm just going to do a very simple program. Oh, it's going to be not so simple. Just realized this is the software side, the PC side of it. I need the firmware side of it. All right. First thing we do is we change that to UPDI01. Now the reason why this is going to be difficult is because I don't do any conversion in the current one. I just simply send the actual bit data out of the registers straight to the PC and let the PC deal with it. So I'm still going to do that, but I also need to now process them locally, and that's where it's going to be a pain. And I also need to set my output pin, which will also be an input pin, PA3. Oh, good. Yeah. I know I can consolidate these, but sometimes, honestly, it's better not to. So essentially in here somewhere I have to do angle equals 18. First I've got to build the what is it? forget which ones are X and Y on these. I think it's the first two and last two. Yeah, it is. Yeah. So the first two bytes are the X, last two are the Y, middle is the Z. So basically this would be use a 5-volt bistable. I prefer not to use the 5-volt in this case, like I said, because then I'm pulling through the regulator. I mean, I could have a latching one, but nah. Each to their own choices, and in the end it may turn out this is just going to be a MOSFET job anyway, so it'll become a moot point. Anyway, so this is the theory of what's written, and then you can sort of go if angle has to be modified though. Yeah, see all this sort of trash. M-pi times 180. And when you do stuff like that in a microcontroller, it blows up. Because, yeah, it doesn't like doing floating point to start with, and then to do that kind of floating point with trigonometry, trig functions, it's like, are you mad? You crazy? Yeah, that's the theory of operation. Now we actually have to make it work, which it probably will not. I do not believe they will have a math in here. Let's see what happens if I compile it. Oh, well, yeah, my bad. Let's see if... And the trouble is, angle is going to want to be a float. Your memory is just getting sucked up. Something severe here. Oh yeah, it wants to program it. Yeah. There's no point programming because it's going to tell me that it's too large to fit in the space. I was about to say, where the hell's my programming header on the board? And I realised I did actually put one in there, thank goodness for that. That would have been quite a hilarious thing to Yeah, here we go. This is when you know it is out of range, meaning it doesn't have enough space. Well, obviously you can't literally explode it. Mind you, I suppose if you manage to make it cook itself, but most of them wouldn't do that these days anyway. So the situation we have now is we need to find a very compact way of, and it doesn't have to be particularly accurate. Like we can pack this down to, um, we can 18, 10 bytes you could probably get away with, maybe 15 bytes. Hey Joho. Of memory space. Actually, I don't even know what the 212 has in terms of RAM. Tiny 212 data sheet. You only discover these things once you've run out of space. Evening, Greg Foster. So what have we got here? So we've got 2K of programmable flash. That's fair enough. We understood. And we've got 128 bytes of static RAM. Oh, that's going to suck. I may have to go for the 214, 412 rather. Because even if I go for lookup tables, I'm going to need 2 lookup tables, and you're not going to cram that into that small amount of space. 28 bytes of. So you're going to have to do it computationally. Let's see if we can find something. Ultra compact 18 to integers. Oops. The input data types are signed 16-bit ints. You can usually work it down to just a pi on 2 radian, and then sine flip and things like that. Could you get away with single hex for 4 bits? Probably not, no. I mean, you might be able to. I mean, like I said, you're probably not going to be wanting anything more than maybe, 22.5 degree resolutions on this sort of thing. So you could probably drop that 16-bit field strength down to 8-bit field strength. So then you're dealing with 2 8-bit XY to then field strengths to calculate the. Really, the way I'm going to do it is that when it comes to the compass swinging out, what I'm going to basically make it is that wherever you say press the button to say this is the on-off position, it will do 270 degrees of on clockwise from that position, and the last quadrant is considered the off quadrant. That's the simplest way to do it, because really, I mean, people aren't going to have a narrow swing. For the most part, it's a case of, okay, I want the off section is going to be comparatively narrow, and the rest of it can be on. So that's sort of how I'm going to go with it. So I think I can drop those. I can just take the high bytes of the registers, and so then we're down to 8-bit and 8-bit, which makes it a lot more compact. The downside, of course, is you're going to get some pretty coarse values coming through on the computer side. But I can compensate that by also sending through an on-off state bit. So at least then the computer can just look at the data coming out of the device and go, okay, it's currently on. We'll also follow suit and do what we've got to do to come on. Yeah. Ooh, it's getting quite too late. All right, look, it's as much as I want to carry on with this, it is a quad to 12. It's taken a little longer than I want, as usual. How entirely normal. But the upside is, we do have a device that is functioning in some form, and I'm just gonna have to pick out some code, experiment with it a little bit, maybe write my own, but it's often easier just to find someone else's genuinely open source code. Need to search for a Cordic algo. I'm not sure what that is. I'll look for whatever that is, yeah. Yeah, it's getting there, and I think I might actually drop the relay situation, and then I'm still going to need to deal with this 7805 situation because I will need the 3 volts, and it's easier for me to dissipate most of it through the DPAC and then do a very small amount off that little SOT23 regulator. Some people say, well, why don't you put a switching regulator on there? It's so much more efficient. And yeah, you're correct, but it's also a lot more parts and gibberish. Just better to take a little bit of a loss in heat. The other way, of course, is if it is plugged into the PC, then we could tap the 5 volts from there. So we just simply have a dual diode situation, and whichever one gets plugged in will be the supplier of the 3.3 rail, the 5 volts for the 3.3. So things like that. Anyway, like I said, we've got a starting point. It's, we've already discovered a few things tonight, and this is how it goes. I mean, prototyping is just like that. I'll show you the box of all the not the ring light, the USB-C meter prototypes. It's crazy. Some of you have already seen this. Okay, obviously that was not one. That was me testing something. Didn't work out. Piece of junk. Don't like them. They won't even work bidirectionally. They're cheap. If you're willing to stick with their limitations, great. But to me, they're just a piece of junk. Let's see. This here is sort of one of the first full functional USB-C meters I had, made from a bunch of different things. So we've got the current sensing here. We've got the AVR there doing all the computations. We've got the display module rigged up here. And then this was probably PC communications. How did I do that? Not sure how I got my PC communications going there, but I did somehow. Oh yeah, I can see it's wires going underneath there. Yeah, so that was one of the first full modules where everything was coming together. That was later on. That's not one of them. This is experimenting whether I was going to go with a large unit, and this here is like the 16x2 version, and it just didn't work out. It was like, I didn't feel like the larger combo was actually what I wanted to use, so that was sort of a dead end. We're doing more and more refinement here. So I'm still using the large CH340s. Trying to think, this is version 3, this is version 1. So this was the first self-contained one. Oh yeah, that's right. And as you can see, the ports are on opposite sides, so that had to be fixed up. And I'm still using the old AVRs on that. This one here, I've got the ports on the same side. Still using the old AVRs. Still using the INA219 sensor, which is good, but and it's good for the standard like 20 volts that we use, but if I wanted to be able to handle the 28 volts, I had to move to a new design. What's this one? This is the one that came before this one. Looks like I've got some bodge wiring going on there. Yeah, more attempts at trying to do the big version. Didn't work out. This here is the very start of it. This is just a normal INA219 current sense situation, and then I've got a I2C to USB bridge, and I was using that to read the values of what was going on and then writing my software for it. So that was kind of like the first functional testing thing. Bunch of cool looking boards that are no use to me. What's this? Oh yeah, my reference voltage is 5.000, 2.500. They still work, they're still good. I use linear references. Anyway. Yeah, another attempt. You got to admit though that what they pack into these, the commercial ones that you previously can buy that keep falling apart, what they pack onto these is truly amazing. I mean, for what you pay, I think it's what, 20, 30 bucks. Yeah, it's a very good value. Have you got an amazing little Bluetooth module? Yeah, it's really good, but they just fall apart, and I prefer to have I don't like having to plug them into the devices. The physical impact on it annoys me. That's the timer. But yeah, so that gives you an idea of, the iterations you got to go through, and that's taken 18 months or so to go from this to this to this, trying out these ones and all that, to eventually getting to what I'm selling today, which is just the one board solution, medium size. I think it hits the mark where I want it. Some people might have wanted the really big thing, but it wasn't for me. Yeah. So if you're only running a couple milliamp microchips, you might not even have enough load for a switching supply. Yeah, that's the other thing, yeah. I mean, with some of the LDO linear regulators, you still got to bleed 10 mil for them to keep them stable. But with the 7805 like that, I'm not sure. I'll have to look at the spec sheet and see what its minimum is. It does feel like it's getting a little warmer than it should, so I've probably got something else wrong on there. Anyway, that's it for tonight. Thank you all for watching. I'm out of here. I'm going to get myself some nice hot malted milk, sit out in the nice cool dark night, watch the kitties run around and talk to my wife, because we don't really get to talk much during the day. It's always busy, busy, busy. So after I finish my stream, it's a chance for me to wind down and catch up on everything and hear about the horror stories of what the damn little furry bastards did while I was sitting in here. So you all take care. I'll see you next time. Thanks again. Catch you later.